Hello, stat fans. Let's get after it today with a little linear regression t-test. So going into this video, I will assume that you have taken notes on the 12.1 PowerPoint. So if that's not the case, go ahead and stop this. Go back to Moodle, find the Unit 12.1 PowerPoint. Walk yourself through that, taking appropriate notes, because everything we talk about here will be under the assumption that you have done that. So today we're going to be talking about a problem that's posed to you on page 754 of your book. So I'll be using some screen shots from page 754 and 755 as we discuss this process. So here you see some of the problem that's posed to you on page 754. This is called example number 4, I think. But we're going to look at this for how to conduct a linear regression t-test. Now you'll notice that they have given you the data. You'll also notice there's an AP exam tip over here. And basically the tip says, hey, just because you're given data doesn't mean that you should start typing it into your calculator. Sometimes everything you will find after having typed it into your calculator is already there for you. And that's the case in this problem. I will add a caveat that here in a moment I'm going to ask you to type that data into your calculator, but it's just so we can kind of verify some things that we see. So I'll give you a moment to read the problem. Now, after having read the problem, on the page, at the bottom of the page there, we see a scatter plot, and then we also see regression output, okay, regression analysis, IQ versus cry count. So in that regression output, locate the coefficient column. And the coefficient column right there allows us to see the value of the y-intercept, known as constant, and then the value of the slope. Okay, so the coefficient of cry count is the slope. The coefficient of constant is the y-intercept. Also important pieces of information, we see r squared right there, which stands which is the coefficient of determination. You simply take the square root of that, and then you have the value of r. Some other things that we see are the standard error of the slope right there. So that's going to be important to us. In this next column, we see t. That's actually the t statistic we'll be calculating later. And then this last column next to cry count is the p-value, and that p-value is always for a two-tailed test. Now this top row, the standard error of the constant and the t of the constant and the p-value of the constant, we pretty much can just ignore those guys right there. So we're really interested in the row that is cry count, and cry count is the x-coordinate for our scatter plot. One thing we might do before we go any further is let's try to interpret the r value, or interpret this scatter plot. And we might say something like there is a weak positive linear relationship between cry count and IQ scores. Now for this video, we're going to be focusing in on parts A and C. So part A, what is the equation of the least squares regression line for predicting IQ at age 3 from the number of cry counts? And then interpret the slope and the y-intercept of the regression line in context. And then for part C, do these data provide convincing evidence of a positive linear relationship between crying counts and IQ in the population of infants? So basically this part here means, hey, do a t-test. Okay, and this test is known as a linear regression t-test. And on your calculator, it's called linreg t-test. And the font on your calculator is almost as beautiful as the font I've chosen. So let's see if you can use the computer output and do part A, which was find the regression equation and interpret the slope and interpret the y-intercept. So go ahead and pause the video and see if you can write that equation. Please write it in context, and we'll get back with you. All right, so here is straight out of the textbook, the equation for the least squares regression line, predicted IQ score. You certainly could have written that as predicted IQ. That would be an okay way to do that. You don't have to write predicted. You can always use the hat, IQ hat, and that is 91.268 plus 1.49 cry count. Then the interpretation for the slope and the interpretation for the y-intercept, you can read off of there. All right, now we're going to focus in on part C. Do these data provide convincing evidence of a positive linear relationship between crying counts and IQ in the population of interest? So this guy right here, this word positive linear relationship basically gives us a one-tailed test. So for test for regression, so our null hypothesis that beta equals 0 basically says that, hey, the slope is 0 or the line is horizontal, and if the line is horizontal, then y really doesn't change as x changes. And so we're seeing if y does change, and with beta being positive, that's going to give us a increase in y as x increases. If beta were negative, we would see a decrease in y as x increases. And if b was 0, there was no relationship, either positive or negative, then y really wouldn't do anything as x changed. Now, typically, the most time-consuming part of a linear regression t-test, much like all of our tests, are verifying the conditions. So we need to verify that the data is linear. We need to verify that the data are independent. We need to verify that the residuals are normal. And then we need to verify that the standard deviation of the residuals are about the same, approximately equal. And then the last thing we need to verify is that our data came from random samples. Certainly no order is important here. You can do these in any way you want to. In fact, we were told that the 38 infants were randomly selected, so we might write that there. We are told the 38 infants were selected, sorry about running out of room here, randomly. Pretend that word showed up. Now, these other parts, the linear part, the independent part, the normal part, and the approximately equal standard deviation parts, well, certainly the linear, normal, and approximately equal standard deviations, we're going to use graphs to show those. For the linearity, we're going to look at a scatter plot. Now, you'll recall on the previous, scatter plot, that's neat. You'll recall on the previous page that the scatter plot was given to us, and we interpreted it as being a weak positive linear relationship between cry counts and IQ. So we would refer to our scatter plot and refer to our interpretation there. For independence, we will assume that 10 times the sample size, 38, is going to be less than the population. So we're going to assume that there are at least 380 infants in the population from which these children were selected. And for the normal part, we can look at lots of different graphs. The one your book uses is one called a normal probability plot. We could also look at, probably, in my opinion, the easiest way to do this is going to be to look at a box plot for the residuals. And then for the approximately equal standard deviation, we're going to want to look at a residual plot. So once we've verified the conditions, then we're going to go ahead and conduct our linear regression t-test. And so the test statistic is t, and it's our slope minus beta divided by the standard error of the slope. And so our slope directly from our computer printout was 1.4929. The hypothesized slope is 0. And again, from computer printout, the standard error of the slope is 0.4870. And if you do that calculation, 1.49 minus 0.48, well, 1.49 is about 1.5, 0.4870 is about 0.5, so you might guess that that value is going to be in the neighborhood of 3, and it is about 3.07. Again, that can be found from the computer output. And then the p-value, which can also be found from the computer output. In our case, I'm going to try that again. The p-value, which is the probability that t is greater than or equal to 3.07, is going to be half of the printed p-value, because the printed p-value was a two-tailed test, so this will be 0.0002. And this is with n minus 2, or 36 degrees of freedom. So certainly 0.002 is less than any acceptable alpha level. So let's see if you can write a correct conclusion for this test based on that p-value. So hopefully your conclusion sounds something like mine. We reject the null hypothesis since the p-value of 0.002 is less than 0.05. There is convincing statistical evidence of a positive linear relationship between cry counts and IQ. All right, sports fans, make it a great day, and I'll see you soon.